Okay, let me get this started. So today we're actually dividing with different denominators. So our goal is to get them to have same denominators. Okay, so we're gonna have to find the LCM. So if you find the LCM between 3 and 4, okay, if you want to do the ladder method, you can. I'll just do a couple this the long way and I'll show you step by step. So there is no other number besides 1 that goes into 3 and 4. So the LCM is all these 3 numbers, right? So LCM is 1 times 3 times 4, which is 12. I'm going to list the multiples. So the LCM of 3 and 4, right? We're looking at multiples, 3 times table. So think of the 3 times table, 3, 6, 9, 12, 15, and so forth. 4, 8, 12, and you can already see that they have something common. The smallest number that shows up in the 3 times table and the 4 times table is a 12. So 12 is your LCM. So you can do it this way or the ladder method. So which means our new denominators are going to be 12. So I'm going to put a 12 over here. I'm going to put a 12 over here. Remember, so 1/3 is going to, we're going to write the equivalent of 1/3 using 12s, and we're going to write the equivalent of 3/4 using 12s. Okay, so how did the 3 become a 12? So, I guess, well, I'll do this. So it's not plus. I don't know why plus, it's division. How did the 3 become a 12? Times what? It was times 4, right? 3 times 4 gave me a 12. So if I multiply the bottom by 12, I hope you remember you have to multiply the top by 4. So 1 times 4 is 4. So 1/3, another way of saying 1/3 is to say 4/12. They are equivalent. 3/4, I'm going to use 12s to replace the 3/4. So how did the 4 become a 12? Times 3. And I'm going to multiply the top times 3, and 3 times 3 gives me 9. So here's my new problem using 12s. I didn't change the value, I didn't change anything, so I just replaced 1/3 with 4/12 and 3/4 with 9/12. They mean the exact same thing, but we're using 12s. So now we got what we wanted, which was same denominators, and we can go back and do this, and that would become 4/9, and that's it. So let's use modeling. I'm going to take something, and I'm going to divide it into 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I need one more here for the second fraction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4/12 is 1, 2, 3, 4. So I'm going to shade 4/12s. Bottom one, I'm going to shade 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So pretend for a second we didn't do the crossing out method and we wanted to find out what 4/12 divided by 9/12 is. Well, how many groups of 9 can you make over here? Because now we have 4/12 divided by 9/12. So how many groups of 9 can I make out of 4? Well, I can't make a group of 9, but I can make a group of 4 out of the what that I was trying to do, out of the 9 I was trying to make. Okay, so you can tell that this answer and this answer is exactly the same. Try another one, 12 and 4. I need to change this, find the LCM. So here's 12 and here's 4. I'm going to do it both ways until you guys... So let's use the ladder method. Got 12 and 4. Pick a number. I'll pick 4. 4 goes to 12 3 times. 4 goes to 4 1 time. Is there any other number? No, so the LCM is this number and the numbers at the bottom. So the LCM is 4 times 3 times 1, and we get 12 again. If you don't like that method, and you should like that method because it's a little bit more convenient, 12 and 4, you can list the multiples. 4, 8, 12, 16, 20, 24, blah, blah, blah. 12 times 1 times 2 is 24, times 3 is 36, times 4 is 48, and you can list them. But if you see something already, yes, we do, the smallest number that shows up in both lists is 12, so the LCM again is 12. So you can do the ladder method or you can list the multiples. So going back to this, we're going to change both fractions to 12. Right? We're going to find an equivalent fraction. So 8/12 is already in terms of 12s, so that stays the same. The 4, we're going to change it to 12. So 4 times what's 12? 4 was multiplied by 3 to get 12. So if I multiply the bottom by 3, I must multiply the top by 3. And 3 times 3 is 9. Now we're ready because our denominators are the same, and we go back and life becomes much simpler. So this time around, I'm going to use models first. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to do the same thing at the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And let's shade in 8 for the first one, right? 1, 2, 3, 4. So I'm going to need up to here. I think 1, 2, 3, 4, 5, 6, 7, 8. Yep, up to here. And the 9 is going to be just one more. So think of this as a grouping, right? How many 9 12s fit in 8 12s? And how many groups? Here's 9. So I want to make sure this whole thing here fits up here. So how many groups of 9 can I make out of 8? I can't make a group of 9 out of 8. But I can make a group of what? Let's see. Let's be able to make a group of 1, 2, 3, 4, 5, 6, 7, 8. I can make a group of 8 out of the 9 I was trying to make. Okay, so I wasn't successful in making a group of 9, but I definitely make a group of 8. That's my final answer. Let's see with the crossing. All right, same denominator, so we can cross this out. Think of them. Just 8 divided by 9. Let's write that as a fraction. 8 over 9. There's no simplifying or anything else that I can get. And you notice that this answer that I get using this method, or this answer that I get using modeling, is the same thing. Okay. I don't think I'm going to do all the questions, but I'm going to do a few here and here. Let's do this one. The LCM of 3 and 5 is 15, right? 3 and 5. I do the LCM. No number goes into both numbers, so just use 1. And we're going to multiply all 3. 1 times 3 times 5 is 15. If you list them, you get 3, 6, 9, 12, 15, and so on. 5, 10, 15, and there you go. 15 is your LCM. So both fractions will have now a denominator of 15. All right, so how did the 3 become a 15? We multiply that by 5. So therefore, I multiply the top by 5. And 2 times 5 is 10. So the next one, how did the 5 become a 15? I multiply that by 3. And therefore, I multiply the 4 by 3, and I get 12. So here are my two new fractions, 10 over 15 and 12 over 15. Okay, so let me use modeling. I like to use modeling first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I need to add one more. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 at the end. Okay, it's a little bit bigger than the top one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, it should have been a little bit better. So here we're going to go 10. So all the way up to 1, 2, let's see if I'm right. 1, 2, 3, 4. No, I'm not. So it's going to be 1 to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. And here I'm going to have 15, 12, right? So I'm going to go all the way here. So again, okay, 10, this is what I have, right? And this is what I want to make groups. Make groups of 12. So can I make a group of 12 out of 10? I can't. But I can definitely make a group of 10 out of what? Out of the 12 that I was trying to make. Okay? And that's my answer using modeling. So I can make a group of 10 out of the 12. I wanted to make a group of 12, but I couldn't. But I made a 10 out of the 12 that I wanted. The other method, cross, write it as a fraction, get 10 out of 12. If you want to simplify it to 5, 6, be my guest. Okay, but either or is correct. Okay, so I'm going to skip around. Let's do one where what we have is a little bigger, so let's do this one. Okay, so 3 over 2, 2/3 divided by 1/2. I gotta find a new denominator, and the LCM between 3 and 2 is 6. How did the 3 becomes a 6? It's times 2. So therefore, the top times 2, and 2 times 2 is 4. How did this 2 become a 6? Well, multiply by 3. I multiply the top by 3, and I get this. I'm going to draw it out. 1, 2, 3, 4, 5, 6. Oh, that's nice. 1, 2, 3, 4, 5, 6. So let's shade in 4, 6 is what I have. And this is what I want to make groups of, right? So I want to make groups of 3 on top here. So what I have is 4, 6 of something. What I have is this. And I want to make groups of 3s. Can I make a group of 3? I can, look. 1. Can I make another group of 3? I can't make another group of 3, but I can make 1, right, out of the 3 that I was trying to do. So I can definitely make 1 full group of 3, and then 1 piece out of the 3 that I was trying to make. If you do the other method where you cross out the common denominators, and they're the same, right? Take the 6 out, take the 6 out, write 4 over 3. And as you can tell, it's an improper fraction. And we're going to change that to a mixed number. 3 goes into 4 one time. You have 1 left over out of 3. Same answers. Okay. I'll move to the next page. Next page, it says solve by crossing out denominators. You don't need to model. So this one is just pure arithmetic here. So let's pick number 8. 12 and 20, you need to find the LCM. The LCM of 12 and 20. Well, 2 works. 2 goes to 12, 6. 2 goes to 20, 10 times. And I pick a number, 2. 2 goes into 6 3 times, and 2 goes into 10 5 times. So and we can't continue. The LCM is going to be this 2 numbers, and these 2 numbers at the bottom multiply. 2 times 2 times 3 times 5. And we get 15, 30, 60. So the LCM is 60. I change both fractions to 60, to 60th. All right. How did this 12 become a 60? I multiplied 12 times 5, so I'm multiplying the top times 5. And 5 times 5 is 25. So another way of saying 512 is to say 25 over 60. Another way of saying 9 over 20 using 60. Well, let's find out. Well, 20 to get 60 is times 3. And I multiply the 9 times 3, which gives me 18. So there you go. Again, I didn't change the value of anything. I just rewrote the 2 fractions using 60s as my denominator. Well, they're in common, right? So I can do this. Let's write that as a fraction. I get 25 over 18. It's an improper fraction. I can change that to a mixed number. So 18 goes to 25 one time. 7 left over 18. That's my final answer. I didn't ask you to model because 60 is pretty a lot. Okay. 7 or 10, 7 or 10, 7 or 10, and we're going to do 7. LCM between 10 and 8. Let's see, 4 works? No, 4 doesn't work. 2 works. 2 goes to 10 5 times, 2 goes to 8 4 times. Nothing else works, so the LCM is the product of all these 3 numbers. 2 times 5 times 4, which is 40. So we're going to rewrite these fractions, having 40 as our new denominators. So 10 times what's 40 is times 4. So I'm going to take and multiply the top by 4, and I get 28. 8 times what's 40 is 8 times 5. So multiply the top times 5, and I get 35. We can cross this out, right? And we write that as a fraction. We get 28 as 35. You can simplify, divide top and bottom by 7, and you get 4/5, or you can just leave it like that. It's okay. All right. So that's that for that. Is there any other that might give you a little bit of a... Let's do 12. 12 is 7 and 18. Ooh. 7 and 18, need to find the LCM. No, nothing works except 1. So if 1 is the only number, you multiply all 3. And you get 1 times 7 times 18, and 18 times 7 is, I have no idea, 126. Wow, ugly. Wow, what an ugly number. Okay, so I'm going to change these two fractions to 126. Can you imagine modeling that? Yeah, not fun. So how did the 7 becomes 126? It was times 18. How did the 5, so times 18 on the top. 5 times 18 is, I have no idea, 5 times 8 is 40, 90. How did 18 becomes 126? It was times 7, so therefore multiply the 5 times 7 as well, and you get 35. Cross, cross, we can write that as a fraction, 9 over 35. We can definitely change this to a mixed number. 35 goes into 90, let's see, times 2. Yeah, times 2 works. Times 3 is too much, so times 2 gives me 70. So I'm going to have 20 left over 35. If you simplify that, you get 10 and divided by 5, 4 sevenths. 2 and 4 sevenths. Your choice. Let's do one more. That's easy. Don't matter. Let's do let's do this one. 9, sorry. So the LCM of 15 and 30 is 30. Okay, I'll do it over here just in case you need it. 5 works 3 times, 5 works 6 times. Then we can go again. 3 goes in 3 one time, 3 goes 6 2 times. So the LCM is the product of all these four numbers. 5 times 3 is 15, times 1 is 15, times 2 is 30. But that's my new LCM. So let's rewrite our fractions. How did the 15 become 30? It's times 2. So I'm going to multiply the top times 2. 8 times 2 is 16. The other one's already a 30, so no changes are necessary. So the only fraction that's going to change is this one. The 8 over 15, it becomes 16 over 30. Okay. We can do this now, right? Because the denominators are the same. And I get what? 16 over 13, which if I turn that into a mixed number, becomes 13 goes in 16 one time, 3 left over 13. Okay, so I think that's where I'll stop because you can do the rest. If you have questions, just ask.